Alright, topic for today is finding common denominators in order to compare. We are going to use this a lot, especially when we start adding and subtracting fractions. It's easiest to tell which is bigger, and it's easiest to add and subtract fractions when your bottom numbers are the same. In order to do that, we have to do a version of an equal fraction, where we multiply or divide the top and the bottom number by the same thing. It's actually pretty simple, but it becomes more difficult if you're not very good at your basic facts. You might have to rely a lot on a multiplication table if you're not very good at your basic facts here. Here's what I'm talking about. Right here I've got a picture of 3/4, and over to the side I've got a picture of 4/5. We have a different amount of pieces in each one of these brownie pans. I tried to draw them fairly similar. Looks like this one turned out a little bit bigger, but just pretend they're the same. This has 4 pieces, this has 5 pieces altogether. My goal is to get it so the pans have the same amount of pieces. So here's how we do it. I need to find a number that 4 and 5 will both go into. And the smaller the better, because then we can deal with fewer pieces. Now, I know that 4 goes into 20. I know that 5 goes into 20. So we're going to use 20. So off to the side here, I know I'm going to use 20. So I'm going to put 20 as my bottom number. Now, we can't just put the 3 up here because then it would not be an equal fraction. We've done these before. To get from 4 to 20, we need to times by 5. And to get from 3 to, not 3 to 20 is what we're trying to do, which we need to times the top and the bottom by the same thing. So I would have to multiply this by 5 also. So my new fraction is 15/20. 3/4 is the same thing as 15/20, so we really didn't change it. So I'm going to come down here, and I know I need to have 5 rows going this way. So that would be 1, 2, 3, 4, and the bottom one is 5. Now if I come over here, how do I get 5 to be 20? That's times 4. And then to keep it an equal fraction, I need to multiply the top by the same thing times 4 is 16. So now I need 4 rows that are going across. 1, 2, 3, 4. Now if you look at our pictures, we've got the exact same amount of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay? We have the exact same amount over here. 1, 2, 3, 4, 5, 10, 15, 20. Now we've got the same common denominator, the same number of pieces in that pan. So it's really easy to compare. All I have to do is count. Well, here I've got 4, 8, 12, 16 filled in. Here I've only got 4, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and that one was filled in 15. So I know that 16/20, which is the same thing as 4/5, is bigger than 15/20, which is the same thing as 3/4. Eventually, you're not going to draw out all these pictures, but for now, I want you to, just so you understand the process of what we're actually doing here. Alright, fractions for this one are 4, 6, and 2/3. And again, my goal here is to find a common bottom number that I could split the number of pieces into. And so what I'm going to do is, I'm going to put equals, I'm going to put my fraction sign here. Now I just need to think of something that both 6 and 3 can go into. Now, if you have troubles doing this, a method that I like to use is, off to the side here, I can just start counting by 6s. I can go 6, 12, 18, and then I can count by 3s. 3, 6, 9, 12, 15, and when I see a match, I can choose that number. Now, looks like we had a match with 6, and we have a match with 12 here. I'm going to take 12 to start with. Okay, so my bottom number, I'm going to make 12, because both 6 and 3 go into 12. So in order to get 12 over here, that's times by 2. So to keep it an equal fraction, I have to multiply the top by the same thing. 4 times 2 is 8, so I have 8/12. Now if I come over here, 3 times 4 is 12, so I have to multiply the top by the same thing, and I also get 8. So I've got 2 equal fractions here, even with what I have here. 4/6 is equal to 2/3. But now I need to draw the picture. This was 4/6. I'm timesing it by 2, so I need to have 2 rows, or two rows here. Okay, so if I put it right down the middle, now I've got 1, 2. Now if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then I should have 8 filled in. 1, 2, 3, 4, 5, 6, 7, 8. I do. Over here, I need to cut it into 4 pieces. Okay, 4 pieces going across, so I'll put one right down the middle, and I'll put one above and one below. 1, 2, 3, 4 I cut it into. So now if I count up, I should have 12 total pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 8 of them should be filled in. 1, 2, 3, 4, 5, 6, 7, 8. So these two fractions are equal, and we found a common bottom number. Remember, even if you knew that 4, 6, and 2/3 were equal to start with, we are going to use this system of common denominators in order to add and subtract fractions later on here. Now, if I come down to this one, it's the same thing, but maybe I want to use a different denominator. Here's an interesting thing we can do. I actually know that 6 and 3 both go into 6. If you notice when we had our numbers up here, I counted by 6's, 6, 12, 18. I counted by 3's, 3, 6, 9, 12. 6 was actually our smallest number that both of those go into. So let's use 6. The nice thing is, over here, we already have 6, so we don't really need to change this at all. This is just going to stay 4 6, which would actually be a times 1 and times 1. Now if I come over to my other fraction over here, 2/3. So we decided our common denominator was going to be 6, and that would 2 would be 6. So I need to multiply the top by the same thing, which is going to be 4. 4, 6. Now I need to cut this into 2 slices going the other way, so I'm just going to draw one line down the middle because that would make my 2 pieces up and down. Now if I count these up, 1, 2, 3, 4, 5, 6, how many do I have filled in? I've got 4. 1, 2, 3, 4. So now I really just need to count up. And sometimes we'll have 3 fractions or more than that where we need to have the exact same amount of pieces in each one. So here's a situation right here where I've got 2/5, 3/6, and 4/10. I need to have a number that all of my denominators will go into so I can make a common bottom number. Now this is some place where your multiplication table may come into play, but again, if you have trouble with this, I would just down at the bottom count by each of these numbers and think of something. So 5, 6, and 10. So if I go 5, 10, 15, 20, 25, 30, 35, let's stop for now on that one. Remember, we're trying to find a match for all 3 this time. 6, 12, 18, 24, 30, 36, and then 10, 20, 30, 40. Now if I look at my list, 30, 30, 30. 30 is going to work for all of these. So I'm going to go 30, 30, and 30. This one is going to be times by 6 to get 30. So I have to multiply the top by 6, and that's going to be 12. So we'll do 6. Let's see, we'll cut it down the middle, and then I need 3 up there and 3 down there. Try to make these as good as possible here. There's my 3 on the top, and my 3 on the bottom, and I should have 12/30ths, and I do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 30 boxes I have now. Coming over here, 6 times what is 30? That would be 6 times 5, so I have to multiply the top by the same thing, which is going to be 3 times 5, which is be 15/30ths, which is exactly half. So I need to do 5 going this way. So it looks like I need 4 lines because then that last one would be the 5th. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. So now I should have 15/30ths, and I do because there's 5 here. That'd be 5, 10, 15 out of 30. And then my last one, 10 times what is 30? That's going to be 10 times 3, which is going to be 4 times 3, which is going to be 12. So I'm going to need to split this into thirds. So now if I count, I should have 12/30ths. I'm going to have 30 because it would have been 10 times 3 is 30, but if I count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12/30ths. Okay? So now if I look at it, I've got two equal fractions here. Those were the same thing. They're both 12 out of 30, and then this one is clearly the bigger one out of the three. And again, we're going to use this future here when we do adding and subtracting fractions. This one I want you to try on your own and see how you do. Now, I put this on here 3 times because I'm going to show you 3 different ways to do it. If you can only think of one way, that's good enough. That's fine. But if you can think of more than one, try it out. See if you can come up with a common denominator, and then pause the video, watch it again, and see how you did. And again, if you can come up with more than one, great. If you can just come up with one, that's okay too. As long as we have one way to do it, we'll be okay. Now, if you had to list 3's and you had to list 9's until you found a match, that's okay. That's not a big deal. Or use your multiplication table. That would be a good idea too. Let's start here. I'm going to start with the smallest one I can think of, which would be 9. Because I know 3 can go into 9 3 times, 9 can go into 9 once. So this would be a times 3, and a times 3 would make this 3/9. So I could do, let's see, times 3, times 3. So I could do 3 across here. There's 3/9. And now if I do times 1 and times 1, that's still 2/9. That's just going to stay the same. Now, a second way to do it. I thought maybe we could do 18. Because I know that 3 goes into 18 6 times, 9 goes into 18 twice. So this would be times 6, 6/18. So I'm going to need 6 going that way. So there's 1 down the middle, and then I would need 2 above and 2 below. These lines are going to get pretty small here. But if you count these up, 1, 2, 3, 4, 5, 6, 6 out of 18. Down here it's going to be times 2, which is going to be 4/18. So I need to just cut this in half. And again, I would have 1, 2, 3, 4 out of 18. The last one I'm going to show you, it's going to be way too small to put this picture in here. But I'm going to do 27. 3 times 9 is 27. So 1 times 9 is going to be 9. Over here, 9 times 3 is 27. 2 times 3 is going to be 6. So we got our same bottom numbers and we kept it an equal fraction. That's our goal here.